Greetings, Math Amigos of Oshkosh North AP Stats class. Today we're going to be taking a look at the notes worksheet that's called Lesson 4.2, Day 1, Does SAT Prep Improve Scores? Let's take a look and see what the question is. It says, last year, EKHS offered an after-school SAT prep class that students could volunteer to take. 44 students took the course and then took the SAT. The average SAT score for this group was 1,220. The average SAT score for all students who did not take the prep class was 1,050. So now they're going to ask us some questions about that scenario, and they're going to want us to determine whether or not taking the class made a difference. So question number 1, is the situation described an observational study or an experiment? Well, what do you think? If it's an experiment, there's got to be some kind of treatment. There would have to be randomly selected subjects. In this case, there are neither of those, so it would be an observational study. It's not an experiment because there's no treatment, and certainly the students did not get selected in a random fashion. They were just selecting themselves. They either chose to do it or chose not to do it. Okay, question 2, identify the explanatory variable and the response variable. Well, the explanatory variable is whether or not they actually took the prep course or not. And the response variable would be what their score was, what their SAT score was. That would be the response variable. So in question number 3, this is where they get down to the bones of the issue. It says, can you conclude that taking the prep course will cause a student's SAT score to increase? Well, you are very astute students, and you probably would look at this situation and realize that no, we can't say that it necessarily would. It might, but we can't say based on this information. Obviously, if someone were to look at the scores, and perhaps whoever is giving this course for the SAT prep is probably going to promote it as, look how much better our students did when they took this course than when they didn't. However, in statistics, we know that this is not really an experiment that's being done, and we need to do an experiment. We need to have students randomly selected, and then some take the course and some not take the course, and then compare when that's over with. It may be distorted when we have students select whether or not they want to take the course, and then those that want to do, and those that don't take the test. So anyway, it talks about number 4, identify as many other possible variables that you can that may explain why the SAT scores are higher for those who took the prep course than for those who did not. Well, these would be your confounding factors. And I guess just because a student did not take the prep course, it might not mean that they didn't want to. They may have wanted to take the prep course. They may just not have had time. But some of the confounding factors would be perhaps the students that took this test is fairly likely, probably close to 100%, that those students do intend to go to college. So they're probably more motivated than other students. Also, there are other factors like the motivational level that the students have for doing well in the test. Maybe they knew that they just had to take it and get a score, and that's fine. Maybe they needed a certain score that they had to get. So maybe there was different motivation. Maybe it's something that they just wanted to see how well they could do. But the motivational levels of the students would definitely play into that matter. You know, if the student used the whole time and reread questions as opposed to somebody that just runs through it and gets it done. Also, the time available for taking the course, as I mentioned earlier, may be a confounding factor. There may be students that just didn't have time. Maybe they were working a job, or maybe they were in sports or something like that. So let's take a look at number 5. Slide it up for you. Design an experiment that would allow us to determine if the SAT prep causes an increase in SAT scores. Be as thorough as possible. Well, if we're going to conduct an experiment, we're going to need to have some randomness about it. So let's say we start with a group of students that are randomly selected, let's say 150 juniors. The juniors are taking this SAT, so let's randomly select 150 of those juniors. Then let's divide those into two groups. Let's have a group that we're going to have take the prep class and a group that's not going to take the prep class. Once again, randomization is important. We need to randomly select which group the students are in. So we're dividing them into two groups, and then we're going to set them on their way. Half of them, or 75 of the 150, are going to take the pre-course, and the rest are not. Okay, then we're going to, once the prep course is done, we're going to have them test and take the SAT test. Then at that point, we're going to compare the average scores of those students who had taken the prep course compared to those students who had not taken the prep course. And that would be an experiment for determining the results here. So next, you flip to the back side of your page, and it's got big ideas and place for notes. I wrote a bunch of those things in there for you. I'm going to put it up on the board in just a moment so you can freeze it. The first time I went through this video, I wrote as I was talking, and I think I could have wrote better. So this time I took my time. I wrote it really nice and neat, and then I'll show you what it looks like at the end. So, all right, so check for understanding. Question number 1, does reducing screen brightness increase battery life in laptop computers? To find out, researchers obtained 30 new laptops of the same brand. They chose 15 of these computers at random, and they adjusted their screens to the brightness setting, actually the brightest of the brightest settings. The other 15 laptop screens were just left in the default setting, whatever that may be. In this case, they suggest it was a moderate brightness. Researchers then measured how long each machine's battery lasted. Was this an observation study or an experiment? Well, as you read through it, you can probably tell it's more than just an observational study. It's an experiment. They started with 30 laptops of the same brand, so they're comparing apples to apples, oranges to oranges. Same brand computer. They randomly selected which 15 they were going to have in the control group and which 15 they were going to use the experiment on. And then they adjusted the 15 that they selected, they put at the brightest setting, and they checked how long the batteries lasted. And the 15 that were not selected, they put on a default or moderate setting, they checked how long the batteries lasted. At the end of that time, then they would take a look and see what the results were. Question 2 through 4 refer to the following setting. Does eating dinner with their families improve students' academic performance? According to an ABC News article, teenagers who eat with their families at least 5 times a week are more likely to get better grades in school. This finding was based on a sample survey conducted by researchers at Columbia University. So they checked and they decided that hey, it turns out that of the students that ate with their families 5 days a week, they tended to get better grades. So they were trying to imply that maybe there's some kind of an association there. Maybe there is, maybe there isn't. But Columbia is a fine university, and I'm sure that they did a good job with their study, although it is clearly not an experiment, which they asked number 2. Was this an observation study or an experiment? It's just an observation study. Observation studies are much easier to conduct. They don't cost as much money to do it. They don't take as much time. And so this is just an observational study. Number 3, what are the explanatory and response variables? Well, the explanatory variables would be whether or not the teen ate with their parents, if they ate with their parents or not 5 times a week. And then the response variable would be what their grades were, how good or bad were their grades. Question number 4 says, explain clearly why such a study cannot establish cause and effect relationship. Suggest a variable that may be confounded with whether families eat together. So we really can't say that there's cause and effect here, because the confounding factor is maybe the teens that eat with their parents maybe they wind up eating more healthy foods or something like that. Maybe they also have conversations with their parents about um, something that would have helped their grades. So anyway, those are some confounding factors. Anyway, at this point, I'm going to put the notes up for you. So this is what I wrote for you before. I know if you were in class earlier this morning, I went through what I wrote when I originally did this video, and I wrote kind of quickly. So here I'm going to slide this up. It looks like my picture is in there. Maybe next video I'll take the picture out. Next video, actually it uses ABC News again. I'm not sure why, so next video we'll talk about the placebo effect, and I'll put that one together in a few minutes. So for this video, these are your notes. You can just freeze it. These are notes I put down for you. You don't have to use the same notes that I wrote. These are just things I wrote. And it doesn't tell you, like for number 4, how many you need. So I just wrote down about as many as I could fit there. And you can adjust accordingly. So this is the bottom part. And feel free to pause it. I'm just trying to make sure my picture isn't in the way. You can pause it and copy your notes if you want to. You don't even have to take notes if you don't want. So this is on the back. I think I'd like to zoom this in because I did have to write kind of small for this. Okay, so observational studies. Those were no treatment was imposed and we only observe. In experiments, treatments are exposed and it allows us to measure causation, which means cause and effect. So that would be some notes for you to put there. I got some more notes here for you. The number of levels of factors or independent variables is equal to the number of variations of that factor that were used in the experiment. So if an experiment compared the drug doses, let's say it was 50 milligrams, 100 milligrams, 150 milligrams, then the factor would have level 3. So the factor would be level 3 because there's 3 different levels of doses that you'd be using in that experiment. So those would be the levels of the factors. Okay, speaking of explanatory variables, what is an explanatory variable? Well, this is what I put down for your definition. You can also get definitions in other places if you want. Your book has good definitions. I decided to go off the board, and I like the Penn State University definitions when it comes to defining terms. So in this case, I use the Penn State version. Sometimes I just use the book version or my own version, but they all mean the same thing. So an explanatory variable, which is also known as the independent variable or the predictor variable, this variable explains variations, and in an experiment, this variable is the one that's manipulated. So they're going to manipulate the explanatory variable. Now, the response variable, on the other hand, is also known as the dependent variable or the outcome variable. Okay, this variable is the outcome that is measured following the manipulation of the explanatory variable in the experiment. So it's what happened, what was the result, what was the outcome. The treatment, that's just what is done to the participants. What kind of treatment did you give them? Experimental units are what or who the treatment is imposed on. Remember, if it's human beings, we call them subjects. I should have wrote that in too, but you can add that in. If they're human beings, they're called subjects. Confounding variables. Confounding variables are variables that affect results but are not controlled by the experiment. They're just things that are confounding the experiment. They affect the results of the experiment, but we're not testing them, and it's very hard to control them or keep them out of the experiment. So those are confounding. I know we went through some of those before. So this will be your check for understanding part down below. These are just the answers. The answer for number 1. You can put it on pause if you want. There's 2 and 3. And you can reword it if you want to. I tried to write my answers in complete sentences, and I then went through later and I just highlighted the main parts for you. So anyway, that looks like about it for 4.2 day 1. Good luck with your assignments, and we will be coming to you again with the next video very soon. So right now, it's your math teacher, Mr. Murphy, signing off from Oshkosh North High School. Stay awesome, Spartans.